right. Let's turn it on. We have 1 minute left. I'm just going to pause the video for a second. Oh, actually, let me just check my sound. Chat sound seems to be good. Okay, so the plan of attack right now is we were going to go over loops and arrays a bit more because A6 was a pain. And we'll look at how we can do that. Let's just do maybe the average of a bunch of numbers. We'll keep it hopefully simple. So I'll have an array with a bunch of numbers, take the average of that array. Okay, and then maybe I'll have do something with an array and a whole bunch of characters, something else like that. Okay. Technically, just because I have some stats background, I get a little anal retentive with this sort of thing. It's called the mean. The average is not precise enough. There's three different kinds of averages: the mean, median, and mode. Three different measures of center, if you will. So I'm going to call it the mean, but we're not talking about being mean. That's what A6 was all about. No, it's about taking the mean of something. So let's do a function called mean. Okay, it's going to return, let's have it return a double, because why not? Mean, and then here's the weird thing about arrays. I don't know how big my arrays are. To put things into context, an array is just a big old chunk of memory that you're getting from the system. You don't know, you don't have any control over any part of that. It just, here's a chunk of memory. And then you're putting stuff in various blocks over those chunks. So very much like, I think of a good example of this one. There's all sorts of examples you might see in other places, but I'm thinking like you ask for a post office box, a PO box. They'll give you a PO box. You have no choice in the matter what they put in, like where the PO box is. But it gets worse. You get a PO box. Yeah, and sure, you get a PO box, and you're stuffing things into the PO box. You don't know where it is. You don't know what it. You just know you have a PO box. Stuff gets shoved into it. If you had little markers in it, you can file little individual parts in it. That's what we're looking at. It's just a sequence of memory that with little spots, I can stick things into it. That's an array. And those square brackets says, yeah, put it into position 4, put it in position 7, some position. So I get a chunk of memory and I can choose where I put things into that chunk of memory. So let's make an array. But I'm going to finish this part by my idea first here. So I'm going to have an array of integers, let's say. I put the a underscore to say, hey, by the way, it's an array. It's not, anything else. This is an array. I'm going to pretend it's an array. That's what I was hoping people would do for A6. And then people are like, you didn't teach pointers. I'm like, don't treat it like a pointer. Don't pretend it's a pointer. It's an array. Just an array. Just pretend it's an array. Ignore all the weird syntax. Just pretend it works like an array like everything else. So I'll call my nums. So I have an array of numbers. How big is the array? I don't know. I got to pass that in. So I'm going to use an unsigned int. The size of my array, a size. I'm going to take the mean. I'm going to sum up a bunch of values, add each one of the numbers to each other. So make a total them up, and then divide by the number of values I have. That's what the average is, right? I have I have for assignment 1, I have a 50, assignment 2, I have a 70, assignment 3, I have that 50, 70, and a 90, let's say. The average, 50 plus 70 plus 90, just to make the math work, divided by 3 is equal to 70. That's what the average is. Okay, so first of all, I'm gonna make an array of integers. This is some weird syntax, but we're just gonna call it nums, not my nums, just so we can see how parameters change as they go into a function. So same, I'm gonna make something called a my nums. When I call this function, I'm gonna make something called a my nums, and it's gonna be pointing to the exact same thing as this array here, a nums. Okay, it has to have a particular size. Let's give it some kind of constant. Just put a hard-coded number in there for right now. And my array I can preamble things, but I can put some values into my array to start. I don't need to, I could put them in later if I wanted to, but I can just put them in to start. So let's, how do I want to do this? Let's put them in to start for right now, at least. So I also want to use some numbers that are going to be making my life easier. So -1, 1, 6, maybe that's not going to help my life, but 6, 7, -7. Let's try that. Okay, how many values do I have? I have 5, right? So that's 5. There's 5 elements here. The array is size 5. We're good to go. Now, if I left this off, the array is size 5. We know how big the array is. But I can double check by putting in the 5 in there. If I put in a 4, it's going to yell at me. Should yell at me. There it is, yelling at me. Right? These have to match. This thing here and this thing here. I could have also just made the array and then filled in the elements afterwards. Okay. So I'm going to call printf the mean of is, and then it's a doubles float. Let's just use an F. It's a long float. It's an LF. I hate that stuff. A float would have just been just fine. Okay, I'm going to call mean, and what am I going to pass in? The first parameter is an array. The second parameter is how big this array is. That's how big the array is. So this thing, when I run this function, it's going to sum up all these values, -1 plus 1 plus 6 plus 7 plus -7. And when I total that up, oh, there we go. Let's make this a. So what's this going to add up to? It's going to add up to the grand total of all these numbers. Because two of them two pairs cancel each other. -1 and 1 gives you 0. -7 and 7 gives you 0. So all in total, summing them up, I'm going to get 6. 6 divided by 5 is 1 and 1/5 essentially. So 1.2 is what I would expect for my value. I want to come up with what my expectations are. And if I'm wrong, well, I figure out if I do my math wrong or if and my program is wrong. Okay, and then I'm going to call that function. I'm just going to call it right in the printf statement, but I could have pulled it out other places. Let's pull it out some other place just to make it a bit more obvious. There we go. Pull out the different place. All right, I need to define this function mean. So what I could do if I wanted to make sure my code is running, just so to illustrate how I work through problems, I could do this. And you're going to go, well, why the hell are you doing this? So return 0.0. All right. Why would I do this? It's not my answer. It's I want something that I could just, I want to kick the tires. I want to see if this thing builds successfully. It doesn't give me the right answer. I don't care if it doesn't give me the right answer yet. I will figure out the right answer later. What I don't want to do is write the entire assignment and then try and figure out where the hell the errors are. That's the kiss of death. I've said this 1,000 times. People never believe me until they get into those situations. And if you had that situation for assignment 6, that's what I was talking about, where you have like, I have 400 errors. What do I do? Do one little bit at a time, make sure it compiles, then do the next. Right? Okay. I'm just going to pretend I have an array called a_nums. It's going to look exactly like this thing here. I'm going to go into individual elements in this array. And for each one of those things, I'm just going to sum them up. So I'm going to make a for loop. Right? I'm going to do two, let's do the for loop version of it. So for int I is equal to 0, I is less than a size. All right. You'll notice that we're going to get a warning about this. I is an integer. This is an unsigned integer, as in it's only positive. I should probably make it unsigned. But still, start 0, go to but not up, go up to but not including a size. So that means 0, 1, 2, 3, 4. 5 elements in total. 0, 1, 2, 3, 4. 5 is where I stop. I don't include a 5. I have 5 elements in this array labeled 0 to 4. The reason it starts at 0 is just because the math works easier for us. That's honestly the reason for why everything's 0-based. And computer scientists are really anal about things because we always count from 0. Okay. And because I don't want to think about things, this is my generic for loop. All my for loops look exactly the same. I have some starting condition. I always started at 0. Why? Because I don't want to have to think. I go up to and including the size of my array. Don't want to have to think. Not all my for loops do this, but this is the generic form, right? I don't even have to think. And I increase by 1 each time. Don't get cute. Don't try and go negative. Don't I minus minus and count from the largest to the smallest or anything like that. Start at 0, go up. Make it easier for yourself. Every time I've gotten cute and tried to do it a different way, it comes up back and bites me. Okay. I'm going to need some kind of total. It could be an int, it could be a double. All right. I need to set it up to some value to start. If I don't, what's going to happen? It's going to get some random gibberish in there, and the numbers I'm going to get at the end are going to be gibberish. I always want to set my variables to start. And now what am I going to do? I'm going to go through each array element, my nums, at position I. It's going to be 0 at first, then 1, then 2, then 3, then 4. And then I'm going to total is equal to total plus that. I'm just going to keep on adding the next number in my sequence. What the heck, let's put a breakpoint in there just so you can see it in action. Breakpoints are your friend. If you haven't used one yet, use it. They save you. Okay. So I'm just going to keep on totaling up all these values. And then at the end, I want to, we have one other weird problem here. We'll keep it simple for right now, but we'll hit a weird problem in a second. Okay. So I'm going to make a new variable called mean. It's going to be equal to the total divided by a size. Except I want to make sure that that total is a double. Because otherwise I'm not going to get 1.2. I'm going to get 1. If I take 2 integers and I do division, I would expect an integer in return, right? You give me 2, trying to think of a good analogy here. If you give me 2 of the same thing, like 2 natural numbers, you would expect a natural number to come back, right? It's just sort of, it's consistent. But I want a double. I want something that has a 1.2, not just 1. So I'm going to cast one of these numbers to being a double, and then it's divided by another number. It's still going to be a double that I get in return. And then I'm going to return mean. Okay. And if you don't know if it's going to do that, drop a breakpoint in and look. It's fine. Okay, let's see what else I have. Is that everything that I need? Let's run it. Let's see what happens. All right. Here is this. All right. So what am I going to do? I'm at this position, my enums. Notice I can't even see what the rest of the elements are in here, but that's fine. Enums up here is -1, 1, 6, -7, -7. So I'm going to go through each element. The size of this array is 5. And I'm going to figure out what each of these values are in the array, add it to the total. So what I would expect is, first time around, I'm going to go F10 or step over. I get total plus, so 0 plus -1 should be -1. That's what total should be worth. Okay. Next time around through the loop, I is now equal, notice what the value of I is, now equal to 1. It's the next element in my loop. I'm going to keep doing that until I get to 5, but not including 5. And the next value in this loop here, this thing here, okay, if I hover over it, it's going to be a 1. So -1, so -1 plus 1 should give me equal 0. See what total says. Hey, still says 0. Great. I can do one more step. Total is now equal to 6, the third element in my array. The sum of these three things gives me 6. I'm going to add a 7 to it. Should give the total of these things should now be 13. 7 plus 6. 13. Great. Now I'm going to add -7 to it, which gives me 6. My I value is equal to 4. And so when the I value increases, the next step, the I value is going to increase to 5. And then I'm going to stop. So I is now should be now equal to, it's going to go 1. It skipped out of that because I would then be equal to 5 and it stops. At the very end, just before I go into the loop again, I do this increase. So right here, I increase it, then I go through the loop and check to see if I is less than the number I'm counting about. Okay, mean is equal to 6 divided by 5. So it should give me some value in here. What's that value? It should be 1.2. 1.2, great. I return it. Notice what happens with my functions. I jump to the other function and then I go back to it. I jump to the other function and go back to it. They're not one after the other. I only have the one main function, and that calls other functions, which cannot call other functions, which can call other functions, which can call other functions. I don't really have a control over. I do have control over it, but I can jump around from function to function. So after I've done this, I should have a value for average. Here I'm back. I finished this. I jump back out here. I finish this function. The average will be set to 1.2, the thing that was returned. It gets stored in this thing here. It's calculating a value and throwing it back out, and this thing over here is catching it. Okay, so the average is now 1.2. I call this function, this is another function, and it should print off the mean of enums is, and it should be 1.2. There you go. And then I'm finished my function, and I'm done. I said there was a problem in here. Did anyone see where the things could go horribly, horribly wrong in here? As an example, it's junk. I'm not allowed to call it. The array has 5 elements. I shouldn't be putting a 0, but I technically could. It's a perfectly valid number to put in here. So if I accidentally typed in a 0, what's going to happen? I'm going to sum all these values up. Actually, I'm not going to have any values in here. It's going to be 0. I'm going to stop right where what I'm doing. Jump down here. It's going to be 0 divided by 0. Oh, crap. So what I really want is if a size is equal, an unsigned integer, so it's equal to 0, return 0.0, something like that. The average of no elements is going to be 0, let's say. I want to do some error checking. I want to call main on a whole bunch of different inputs. Should still work. Nothing has changed really. Okay. Uh, and we could also do this for another set of numbers. Let's leave that out. And actually, let's put it in. Is equal to 1. Let's do this. Let's do it this way. I'm going to use a for loop to fill in this value. I know I have 6 elements. 4 and 0, 5 less than. Let's make that as 12. So let's call this constant int. Well, if you know your math, you'll know why it's called sigma size, but otherwise don't worry about why it's called sigma size. Sigma notation, it's the sum of series of numbers. I'm going to make that sigma. It's a constant. I'm allowed having a constant in here. I cannot have a variable. Can't change this, but a constant's not allowed to change. So this is 6. No matter what you do, you cannot change this value whatsoever. That's why it's allowed to be global. I'm allowed to have it outside of my functions. But it's 6. Rather than hard coding the value 6, I can put a variable in there. I can have something saying, okay, every time you see sigma size, it's equal to the number 6. The reason I want that is because if I want to change it to 17, I don't want to have to change the values a whole bunch of places. I want to change it once. Okay. And I is less than sigma size, I plus. I'm just trying something out here. I want to set the values to something, right? So what if I'm making a brand new array, size 6. I'm going to give it 1, 2, 3, 4, 5, 6 as the values. Or it's actually 0, 1, 2, 3, 4, 5 as the values. We could do 1 to 6. Let's do 1 to 6. 1, 2, 3, 4, 5, 6. Now, if you know anything about a summation, the sum of the first n elements, you know what those values might be. So let's keep it simple. 3 plus 2 plus 1 is 6. Or we can do it, let's do 4. So 3 plus 2 plus 1 plus, so 4 plus 3 plus 2 plus 1 is equal to 10. The average of those values should be, I have 4 different elements, so 10 divided by 4, right? So it's 2.5, 2.5. Should be 2.5. All right. So I'm just going to sum up those numbers. Okay. And then I'm going to also do the same code right here. Oh, I don't want that 0 anymore. So 5. This is going to be, I want to use the, okay. So the average, let's call it average 2. Very original. Okay, I also need to change this variable here. So I'm just calling the same stuff again, but this time with a different array. It's fine. That's why we use functions. So you're not copying and pasting the same, a large chunk of code over and over and over again. I'm trying it with 2 different arrays just to see what would happen. Let's compile it and see what happens. So with 4, it should be equal, I should get 2.5. Okay, let's see what I get. 2.5. Hey, that worked. Great. We could try another thing. We could try 5. So That is 15. So mean of 3, right? If I add the first 5 numbers at 1 plus 2 plus 3 plus 4 plus 5, I think that gives me 15 divided by 5, what number of elements I have, should give me 3. But notice I didn't do anything else. I didn't change my code at all. Sigma size, sigma size, sigma size. And as long as I don't hard code in a value, I change everything by just changing one number. I just change this right here and everything else change. I should get completely different output. 3. Sorry, you can't see that. Here you go. 3, just by changing one number. I will give you a warning in advance. If you try something really ridiculously big, that gets out of hand really quickly. The summation of the first 20 numbers sort of explodes. Essentially, it gets huge. Okay, that is me doing the average using a function using an array. I have an array that I've made without defining the values inside, and then I used a for loop to fill in the values. My for loops always start at 0, go to some stopping condition, I plus plus. That's how I do things, at least. And my and then my average itself, when I pass it into a function, it looks like this, but it acts exactly the same. I don't need to do anything different about this. I just, okay, go to position odd. There is no change. There's nothing different than what I did before. But I don't know the size of my array unless I have to tell the program what the size of my array is. I can't find it naturally, which is a weird concept, but it is what it is. Can I unpack anything else for people? Because there's only 4 of you right now. I was asked to do for loops, arrays. I'm more than happy to do structs next. Um, but I was going to go to a character array and show a while loop. I'm not sure if this is, hope it's not an exam or something like that, but it's a nice simple, hopefully simple thing. Okay. Uh, yep, that. We're supposed to do for the function dropNLowest for A6. Okay, we can do that as well. Oh, can you also possibly clarify the materials we need to study for the midterm exam? So midterm is a bit of a misnomer, but still, we'll have a look at this. So the midterm exam goes all the way up to, I don't think I'm doing dynamic arrays by that point in time, but we'll have arrays, we'll have structs, we'll have for loops, while loops, all of our loops, all of our conditionals, all of our variables. We looked, oh, I may have to change my exam a little bit. We looked at data structures and the size of different data structures and how, how big is an int versus how big is a double? How do you convert from one to the other? What is boost complement? What are the various binary representations of things? We looked at, let me think of some other things we've looked at so far this term. Um, by the way, and if we did it before, like if I asked for pseudocode, technically I could ask for pseudocode again. Right? It's all the entire class builds on itself. It's not psychology. I have a psych degree. I know what a psych class looks like. It doesn't look like that. It builds on itself. So when you learn one topic, it then is applied to the next topic. So anything that we've done up to and but not including, I think, dynamic arrays, fair game on the exam. Even dynamic arrays, you should know them. Pointers, definitely not on the exam. So that would be that's the hard line. That's definitely not on the exam. There are no pointers yet. We'll be hitting pointers, talking about pointers the week of the exam. That's the reason that they definitely are not on the exam. That hopefully clarify things. You can be asked to program something. You could be asked to find errors in code. I often have some multiple choice questions. They are not necessarily easy at all. It just means that you don't get people that you have a 2% on an exam. It sort of means that the lower bound of someone's grade ends up being like 10, 20%. But most people, the upper bound also goes down a little bit and gets up to like, say 10, 20% up to 90 or 100%. How to use, okay, and we can also do user input for structs. Okay, how would we want to do that? Oh, okay, let me put that in there. Oh, user input for that. Okay, I'll make a triangle class or triangle struct. Maybe square. Or, trying to think of what kind of numbers I want to have. Let's do triangle. It's in the lab. Okay, and what else did we want to go over and drop in Lewis? Okay. So that average, by the way, it's going to be the same as almost no matter what. Uh, the one difference between this mean, this average here, and what we did on the assignment is I had a special kind of way of summing things up versus not this way, special way of summing things up where I ignore things that have the ignore all value. The point of that was that I could remove, sort of artificially remove individual elements from my array. Because I can't, once I get a big chunk of memory, I can't modify the size of it. It's a chunk of memory that's mine. I can't change the size of it. When I ask for a postal code or a PO box, or if I ask for a storage bin or storage container, right? I don't get to choose afterwards. I don't get to like, I'm going to just cut into the next person's storage container. No, you're not allowed to do that. It's the size of the storage container. You paid for that storage container. You get that storage container. You cannot change the size afterwards. So that's what we're looking for when it comes to, that's one of the limitations we have to work around when it comes to arrays. Okay, so let's do, I'm going to do character count first just to see that's in action. Okay, constant char. Actually, I could, I think if I can do it this way. It's a weird thing for character arrays. I'm able to do that. Okay. I'm just going to keep it the old fashioned way. Okay. And, and it's an array. I don't know how big this array is going to be, but I'm going to be determining it by this. So a, and what we did with the assignment was we had this thing at the end. The reason we have this thing at the end is that actually is how, when we hit strings, we'll see it's also on the exam. When we hit strings, this determines this special character. It's only for character arrays. It's only for text. It allows me to know the length of the string without necessarily passing in that value. When I get to this thing, I say I'm at the end of my string. I could have, the array could be way bigger, but when I get to that 0 at the end, this value right here, this special character right here, it says, okay, stop. Stop what you're doing. That's the end of the string. Okay, so that's the text I'm going to be dealing with. And I'm going to print f that text. We'll find out that it looks exactly like a string that we were dealing with before. As char, hopefully this will work. See in it text. I have character and I'll get to what the heck that's going to do in a second. Okay, so I just want to keep my things a bit simpler for myself. I'm going to look for the character L in this string. So I should have two instances of the character L in this array. That's what I'm looking for. That's what this thing is supposed to be doing. Next up, why is everyone on my thing for Discord? All right. So I'm looking for the character L in this big old string. That's what I'm looking for. So I should return the value 2. And name of my function is char count. Char find the thing I'm looking for. The text I'm looking for, a text. And I set the size of this thing here. So let's count them up. 1, 2, 3, 4, 5. There's actually 5 characters in there. There's actually a 6th one at the end. So let's say 6. The character string has 5 characters in it, but there's a 6th hidden invisible ninja character at the end. At this thing right here. Okay. So I'm going to call that. That's all I'm doing. Let's actually define this function down here. Well, actually, we don't even need to define that function yet. Let's put a fake thing in here for now. Make sure everything runs. That's why we do that. Okay. Unresolved. Let's see, maybe I have a syntax. No. Char count. Okay. Char count. That's the name of the function here. Char count is defined right here. It's not a defined function yet. That has to be defined because I'm missing a character at the end. That's what the problem is. All right. See, I want to do a little bit at a time rather than all at once. Should work now. All right, it works now. The name of my function, the parameters, I was missing a parameter in there. Let's run this. What it should say is 0 every time. Why? Because I don't know what it's going to say, but I just want to test my code to begin with. All right. Char L is in it 0 times. Okay, well, it's not actually only in there, but text hello has character L in it 0 times. Yes, L and 1 looks like a 1. Sorry, but that's what we're doing. Okay, now I need to actually do this. So let's use a while loop. Why not? And then I'm going to have what does a while loop look like? A while loop is some condition that I'll keep on looping around doing the same thing over and over and over again until this thing is true. So, sorry, until this thing is false. So while I want to say index is less than a size and a text at position index, if at the current position is not equal to this thing, the stopping condition, the thing I'm saying, yeah, if it hits that, stop. This would be one version of a while loop. So as long as the index is less than the size of my array and the character at the index position, the position that I'm looking at, it's 0, 1, 2, 3, all the way up, right? As long as that character I'm looking at is not equal to this special fancy ending character. So if this ends up being true, if this, while this is true, so if it ever ends up being equal to that, stop. If index is ever greater than or equal to a size, stop. If, as long as this thing is true, well, we keep going. Otherwise, stop. Okay, unsigned int char count, let's say some starting value. I'm going to return that at the end. And every single time I find the character I'm looking for, increase the char count. So I'm going to go next char. So index plus plus, take my index, increase it by 1 each time. This will go through my entire array until I get to that 0 or until index is equal to a size. Okay, now we need to check things. If a text at position index, that's going to change each time. It's going to go from 0 to 1 to 2 to 3 to 4 all the way up. If that is equal to the character I'm looking for, so to find the character I'm looking for, char count plus char count plus 1. Make it simpler. Simpler way of writing the same thing. But if it's equal to this, if it's the character I'm looking for, increase the counter. At the end, return how many I've counted up. Let's have a look. 2 times. All right. I don't know if this always works. Let's try something else. Let's try, we're going to look for character E. Should only occur once. One time. Okay. Let's try another one. Let's try, we're looking for the character, something that's not even in there. Capital E, not in there. So lowercase e, they're different. I should get a 0 in this case. There is no uppercase E in this string of text. 0 times. Hello has character E in it 0 times. My function's working as the way I expect it to. That's me doing a while loop, showing how a while loops works on an array as well. And I need to make sure, by the way, if I don't have this in here, I get an infinite loop. The index never changes. It stays at 0. I keep checking the same spot. It will never change. I never go towards a stopping condition. And I have an infinite loop. It'll slow your computer down to a crawl. It is bad. Do not, first thing first, when you make a while loop, make sure you know it's going to stop. That's the number one rule always when it comes to your while loops. Okay, let's look at what we had. We had dropNLowest. Okay, let me try and not hand wave, but deal with that. And I also want to make sure we hit structs, and we're running out of time. So I'm going to do struct of a struct, hopefully. Yeah, and we'll do it that way. Okay, later on. So what did I need for the dropNLowest? I needed some way of finding the minimum value, removing that minimum value, and then, by the way, the homework 6 solution, if it's not posted, I need to post it because you should have access to that code as well. So if I find the minimum value, I find the minimum value, remove that value, put in a ignore value in there. Keep calling find minimum value. When I do that enough times, what that's going to do is it's going to remove all my lowest values that I have in my array. When I'm done, and then I can sum up whatever's left, divided by the number of those values that were left. And that should be my average, well, after having dropped n values. So, okay. We'll want that. Value in here, and I will. It's going to be the exact same thing as the assignment, but so let's call it num drop. Okay, so mean drop n. I'm going to get the mean of the number of values that I've dropped. So what I'm going to do is I'm going to remove n of these things, the number dropped. I'm going to remove that number of elements. So if this was 13 and this is 5, I'm going to keep 8 left. No matter what, I'm dropping 5, which is not realistic. It should be how many I'm keeping or whatever you want to call it. But let's assume I'm going to keep. This is the number of elements I have. This is the number I'm going to drop. I'm going to keep on removing elements from this thing, but I can't change my array. So I need some way of removing removing elements that are my lowest. So constant int. This is what I was doing at least. That's never going to be found. Okay. Int. I'm going to get my min index. Move those over, and so I've got that. The counting the number of valid values, it was more for an error checking. It shouldn't actually change my code, but it's a good solid thing to error check. Okay. Okay. Oh, the min index, I actually want it to be an integer. The reason I wanted it to be an integer is if it returns -1, it's not a valid index. Just one way you can do things. Okay. So my minimum index, what I need to say is if a size is equal to, so what do I need to do? Okay, I'm going to keep on finding the minimum. Less than a. If this is greater than a my nums at position I, so if I have found a brand new minimum, all right, if is safety precaution, return 1. I could also use, let's use a ternary expression just to show that. If it's equal to that, do that. Otherwise, there you go, ternary expression. Return min index, done. So all I'm doing is walking on this thing, find the minimum index. All right, dropping the n lowest. What am I going to do? I'm going to have how many am I going to do? The number I'm dropping, I'm going to do that number of drop times. So, okay, so 4 I is equal to 0, I is less than, I just want to see what's going to happen here. So I'm going to call it n number, num drop number of times. So if it's 2, I call this min index. And then I'm going to remove the value from the min index. Okay, so a I nums. That's what we do there. So I'm going to call min index is equal to min index. All right. I'm doing wrong here. Why is that not working? I think it's just because they have the same name. Okay, so I'm also going to put in assert here. I'm going to assert, at least for right now, just as an error check for my case, that I always have the right number that I could throw out. I could do a better way than this, but this is the fast, quick, and dirty way of doing it. Do I have assert in here? Yeah, I have assert in there. Right. So I find the minimum index. I'm going to say it can't be equal to -1. Otherwise, I didn't find a minimum index. I'm going to then set this value here at this position to ignore value. If I do that n number of times, I have a different minimum index. And then what I'm going to do is I'm going to do what I did with mean, but take mean all over again. Okay, and I normally have a function to do that, but I'm not going to do it with a function. I should, but if that function was actually given to you on the assignment, sum up all those things. All right, double the mean ends up being just total divided by, it's not just the size, it's the size minus the number dropped. That's how many I'm keeping in the end. And that would do it. There you go. That's effectively the solution. Okay. I want to hit structs because I know that they're in the next assignment, but I wanted to, it's not, I gave you the function that does this, that was given to you. This is the one little part that was different, but finding the minimum index, you had to write that, finding the index that is the smallest value. This is the weird, quirky puzzle part of it, but that's why you do it on paper first. So because you don't necessarily keep it in your head, you do it on paper and you'll suddenly go, oh, that's what I do. How do when I remove it? I find the smallest value, remove it from my list. Find the smallest value, remove it from my list. And then I just sum them up, divided by the number of valid values I have around. That's my mean. Okay, I want to do something with structs right now. So here we go. I'm going to make a struct. Notice my structs are always defined outside of my functions. So struct, let's call it a point x and y. I'm going to have another struct called a triangle. Did we? Okay, so let's see if I have this. We want to input for structs. Okay. Why do you only want to run it twice? I have the number that I'm going to drop, so the for loop does that for me. Oh no, let's look. Hopefully, maybe my code is wrong. The number dropped. That's the number I'm dropping, not the size. So this could be 11. This could be 2. I'm removing 2 values. I do it twice. Find the minimum index, remove it. Find the next minimum index, remove it. There you go. Little subtle things, but those are the things that take it line by line, essentially. All right. Nice question. Here's a triangle. I'm going to put a point in a point. I'm sorry, a struct in a struct. Because I can. Okay, so here we go. Point P1, point P2, point P3. I could have an array inside of a struct. I can have an array of structs. I can do all sorts of weird things. That's actually the point. I can do all sorts of new things once I have a structure because it tells me how this thing should look. It will have 2 numbers. Each point will have 2 numbers in it. I have 3 points that defines a triangle. And I'm going to make a thing that's going to make a triangle for me. So, and I can return all, what is this? 6? Yeah. All 6 integers, essentially. Point 1 has 2, point 2 has 2, point 3 has 2. There are 6 integers in total inside this struct, 2 in each one of those points. I can get all 6 of those values and pass them all out of my function by using a struct because it wraps everything up together. So I can return a struct. Get triangle from user. Don't even need input. Okay, I'm going to call this function get triangle from user. And it's going to make a triangle data structure. I'm going to, so here is my dealing with structs. I'm going to get a triangle from the get triangle from user function. Maybe what could I do here? Maybe I want a printf statement in this thing. Let's do it this way. So lazy. All right. I have 6 numbers I have to put in here. Try dot p1 dot x, try dot p1 dot y. That's the first 2 numbers. Try dot p1 p2 dot x, try dot p2 dot y, try dot p3 dot x, try dot p3 dot y. Okay. Yes, it is that big of a pain. I'm going to take each of those. I can go to each individual element. I can go struct within a struct. I just need to put another dot and I go to the inside of that struct. Dot of a dot of a dot of a dot. I can do all of these different things. So this is going to make a structure. This is going to make a structure, getting it from the user. This is going to and return it. I save it here, triangle try. This returns a structure and I just save it in a new variable called try. And then I'm going to print off the 0.1, 0.2, and 0.3 values for the triangle. Way more complicated than the Chinese zodiac. Chinese zodiac is going to be like month, day, year, 3 integers, done. Nothing special. It will literally, that's the only structure you have to do. 3 integers, month, day, year, and I can pass that as 3 numbers. The point is 2 numbers. This would be just 3 numbers, and I can pass those around. Pretend it's like an integer. It's a variable. I just pass it around and pick it up on the other end. It's me making my own data type, essentially. This, in fact, this structure has a grand total. Each point is exactly 64 bits large. It's two integers, each are 32. So 2 times 32, 64. And the triangle data structure is 6 times that amount. If I did the size of a triangle, and size, do that. One more number here. We haven't done size of yet, but we're going to see it very, very soon. The size of my triangle data structure. And we're going to see how big that thing is. Okay, now I need to define this thing here. In fact, I'm not going to do much about this at all. I'm just going to go down here. Again, I'm just going to put some fake amount in here, or I'm going to put a function in here, not do anything with the function. Triangle T. Oh, try again. Turn try. I didn't even initialize anything yet. I'm just making a triangle, passing it back out. The reason I want this is I don't want it like this. I'm just going to make it build. Oh, see, that's why. Okay. So what is going on here? So I have a struct called triangle. Oh, it's just not initialized. That's why it's yelling at me. Uninitialized. Oh, I do need to initialize it. Damn it. Okay. Again, I'm not even doing the scanf or anything like that yet. Oh, P1, P1, P1. I'm just going to set some values up. They're safe values. It's all going to be 0, 0, 0, 0, 0 everywhere. I want to see what this does. All right, let's see what this thing gives me. 0, 0, 0, and size 24. That's the size of, by the way, is the number of bytes. So 8 times that amount is how big this thing is. The size of an integer is 4 bytes. So this is 24. See, 4 times 6, 24. Hey, it works. I can check my math, right? Each integer is 4 bytes. This is 6 integers. 6 times 4, 24. Great. Let's actually fill this stuff in. I just put some safe values in here for right now. Let's actually get user input from the user. So printf, please enter in values for point 1. Okay, and I'm going to attach. I'm using a scanf, so scanf. And what do I want to put in here? I want to put, this is what scanf looks like. I'm going to be putting in a single integer into this thing. It's going to be going into a particular point. Let's keep it simple for ourselves. Let's call it use p1.x. And the weird thing is that thing you have to take on faith is you just need to put an and in front of that whole thing. And if I want to be paranoid, I'm going to put parentheses around that. Okay. p1.y. Okay. So I'm putting in input from the user 2 times, or 2 inputs from the user for X and for Y. What I could do then is, this is painful, but you can do it this way. Every time I do copy and paste like this, I should be scared to death. the right thing to do, maybe use a for, not even a for loop. I don't know how, I know I have exactly 3 structs, but for point 2, I would want to, if I'm not improvising something on the fly, I want to think about it first. Okay, this is the issue I'm going to have. I want try P1, try P2, try P3. Okay, so try.P1 is equal to P1. Fine, but what I want, I'm just getting P2, and I could have gotten it directly without going through another point. Let's call it P. Change it everywhere. Can I do that? That's going to be a lot of changes. Yeah, I'm going to do that. Okay. So, oh, I can probably refactor, rename. Let's see if I can rename it straight in here. Rename. Okay. And instead of P1, I'm going to be using, instead of P1, it's going to be PT. Can I do this? I've never done this before, so let's find out. No, it's going to change my struct as well, I think. Yeah, let's find out. Oh, it didn't change that one. It only changed this one. So PT, PT. That actually may have worked. What a miracle. Okay. So I've never done that before. So I have a pointer, a point called point, very original. Uh, I set the values to 0, 0. I've set some things to set the safe values. That's what I'm doing, safe values. All right. But now I'm going to get information from the user for point 1, for point 2, and for point 3. And then I'm going to shove it into the 3 different parts of the struct. Then return the triangle at the end. Okay, return value is ignored. I was trying to ignore it, but that's fine. I'm not sure if I should be using the underscore S1. Notice now what the problem is when you copy and paste though. If I had to change all of these things 3 different places, I'm doing all this extra work, and you want to be lazy. So ideally what I want to do is just get the point from the user. Maybe I should have that as a function. Get the point from the user, and it returns the point, and you put the point in your triangle. Actually, it's much better a solution. That would be the better solution. Let's see what we have here first before we do that. Please enter the values for point 1, 3, 4, 9, 17, 33, 22. Just random numbers. 3, 4, 9, 17, 33, 22, and size 24. It got me the 3 different points, put them in my triangle, one after the other. This printf statement just says what I have. All a struct is another way of, because I'm making my own variable type, it allows me to return the whole structure, which returns a whole lot of different points versus an integer, like one integer. Instead, I can return 6 integers because I'm using a structure. That's one of our workarounds for limitations on I can only return one thing. I can return a structure, and that structure can have a whole bunch of different variables inside of it. Okay, let's do that one thing actually. Let's make get point from user, is the name of my function, it's going to return a point, and I'm doing this. And I will have some point, a point. Hopefully that's not going to barf on me at all. Get point user. It's going to be equal to that. Okay. So instead of copying and pasting that scanf everywhere, I could have done this. Why do I want functions? Because I don't want to have to repeat. Like this is, if I have to change this, I change it one place and it affects it everywhere. All right, so this could get me, and I could reuse this some other time. If I want to use this later on, I can make something so that I just get points from the user. Simple as that. And I don't have to worry about like, oh, but on a Tuesday, just gets me the points from a user. Let's make sure it runs. I also need to look into this thing here. Right? Num dropped is unsigned integer, so therefore my counter should be, my index should also be unsigned. Okay. Okay. Yeah, that should do. Okay, so let's make it 1, 2, 9, or 8. Can't type 1, 9, 3. Hey, that worked as well. Okay, that's all we're doing with some of with the labs. That's what we're doing. We're just grabbing user from the input from the user. Here is, I have a printf statement, but the actual scanf is only in here. I'm getting input from the user, putting it into a pointer, a point data structure. I'm putting in the y variable. I could have also stored it as a separate value, just popped it in there afterwards. But I'm putting an integer in the point named pt at variable y. Does that make sense? Danny, did that, hopefully that was useful? Yeah, absolutely. It's intentionally a little bit obfuscated, right? Because I wanted to show something with a little bit of meat to it. A point structure has an X and a Y. A triangle has 3 points. So to get the X for the first point, it's whatever my triangle is named try, let's say, dot P1 dot X. The X in point 1, which is inside the triangle. And I'm wondering where the heck your error might be popping up. The issue is that people get concerned about when they hit errors, and you're like, errors are unfortunately par for the course. And they're really obscure errors. And sometimes it just requires you banging off your head off the table, or more importantly, going for a walk away, come back in like 20 minutes time. You'll have a fresh set of eyes. Right? And if you do a little bit at a time, you can at least deduce what the heck's going on. Because if you do everything at once, some error at the very top could be causing all these errors later. You want to do a little bit, test, a little bit, test. Hopefully that was useful. All right, we're about to be completely out of time, and I'm about to fall over from not eating lunch yet. Can I help anybody with anything else? We just did a struct, which is going to look very similar to what we did for the assignment 7. Assignment 7, it doesn't have to be fancy. It is, you figure out the year, you figure out if it's past February 12th or February 12th or onwards. If it's before February 12th, technically like the year before, pretend it's the year before. So if it's 2011, but it's February 11th, it's actually 2010. Just pretend it's a year earlier. From there, you're fine. Once you figure out what the actual zodiac number is, you can then spit out what the text is for that zodiac number. If it's an 11, or let's say it's an 8, if it's an 8 and that's the year of the dragon, then you just spit out dragon when someone asks, "Hey, what's your zodiac sign?" It says the zodiac number is 8. Oh, it's dragon. So that's one of our parts. And then you take two zodiac numbers like 8 and 4 and see if they're compatible. If they're 4 off from one another, they are compatible. So 3 and 7 are compatible. 4 and 8 are compatible. 0 and 0 and 4? Yeah, 0 and 4 are compatible. That's it. And how do you know that they're off? Well, what's 4 minus, or let's do 8 and 4. 8 and, or 7 and 3. Let's do 7 and 3. What's 7 minus 3? 4. Is that divisible by 4? Yes. Done. Is 2 divisible? If the number was 2, was it divisible by 4? No, it's not. How about 3? No, it's not. All I need to see is if it's divisible by 4. We already know how to do that. We had remainder, remember? So that hopefully should get you on the path if that is something that was holding you up. All right. Anything else? Otherwise, I'm going to stop the video and stop sharing at least. This code, by the way, is always online, so you can just grab it. I pass off a link to it every single one of those synchronized emails. I pass off a link to our folder full of in-class code. And there's only 2 of you now. All right. All right, perfect. Well, thank you very much, guys, and I will hopefully talk to you very soon. Let me know if you have any other questions come up.